In this video, let me consider one numerical on to design FIR bandpass filter. The frequency response of an ideal bandpass filter is given by HD of omega is equal to e power minus j3 omega for omega in between 1 and 2 and 0 otherwise. Design FIR bandpass filter which approximates the above filter using Hamming window. The same question can be asked in another way as design bandpass FIR filter using Hamming window, take m equal to 7 given that lower cutoff frequency omega c1 is equal to 1 radian per second, higher cutoff frequency omega c2 is equal to 2 radian per second. Obtain magnitude response. We'll try to find the solution for this. The normalized magnitude response of an ideal bandpass filter is shown below. So here we know that this is the magnitude which is represented as HD of omega, which is also represented as HD of e power j omega. Both are same. Here we can see that the magnitude value is, that is e power minus j 3 omega when omega is in between 1 and 2. That is, this is 1 and 2, this is omega axis, and here it is minus 1 minus 2. As it is bandpass filter, we have two bands here. Its value is 0 if omega is less than 1. So here we can see that from minus 1 to 0 its value is 0. Similarly, in between 1 to 0 the value is 0. As well, when omega is greater than 2 and less than pi, its value is 0. That is, if we consider this as minus pi and this as plus pi, here we can see that 2 to plus pi it is 0 and minus 2 to minus pi its value is 0. So in this case it is given e power minus j3 omega. As we know, the general form of representation is e power minus j tau omega. So comparing this with this equation, comparing this with this expression, I can write tau is equal to 3. So as we know, tau is also equal to window size m minus 1 by 2. So here tau is equal to 3, which is nothing but m minus 1 by 2. Therefore I can find 6 plus 1. Therefore I can say m is equal to 7. So here we can see that in this example or in these statements, it is said that design a bandpass FIR filter using Hamming window, take m equal to 7. So in this example, m value is directly given. In this example, m value is derived from tau value. Therefore I can say these two are same. And here we can see that omega c1 value is 1 radian per second. The same thing is written here, and omega c2 is 2 radian per second, which is nothing but this one. So in design of FIR filter, the very first step is we are supposed to obtain desired unit impulse response HD of n. That is the desired unit impulse. So HD of n is nothing but taking inverse Fourier transform of HD of w. We'll get HD of n. So it is defined as 1 over 2 pi integration minus pi to pi HD of omega into e power j omega n into d omega. Therefore I can write here HD of n is equal to 1 over 2 pi. Here we can see that at this band, if we consider this band, here it varies from minus 2 to minus 1. So I can write it as integration minus 2 to minus 1, and the magnitude response or frequency response is e power minus j3 omega. That is e power minus j3 omega into e power j omega n into dw. Similarly, I will consider this band which exists from +1 to +2. So I'll take one more integration, that is for +1 to +2. hd of w is same, that is e power minus j3 omega into e power j omega n into d omega. Now let me simplify this. That is, I can write hd of n is equal to 1 over 2 pi. So I can also represent the above equation as e power j omega n minus 3 d omega. Here if we take j omega as a common, we'll get n minus 3. Similarly, for this integration also I can write, that is 1 to 2 e power j omega of n minus 3 d omega. Now simplifying further, that is hd of n is equal to 1 over 2 pi. So integration of e power j omega n minus 3 is given by e power j omega of n minus 3 divided by j of n minus 3. So to this we supposed to apply the limit, that is minus 2 to minus 1, plus for this integration it is also same, that is e power j omega of n minus 3 divided by j of n minus 3. For this the limits are 1 and 2. Close the bracket. Now let me simplify this further. I can write hd of n is equal to 1 over 2 pi. So here we have e power j minus 1 n of n minus 3, that I can write it as e power minus j of n minus 3 minus, we have minus 2, that is e power minus j 2 of n minus 3 whole divided by, I can write j of n minus 3 plus, similarly for this part I can apply the variable omega for 2 and 1. I can write it as e power j 2 of n minus 3 minus e power j 1 into n minus 3 divided by, we have j of n minus 3. So I can write it as hd of n is equal to 1 over 2 pi. So I'll take jn minus 3 as a common denominator, it is LCM. It is e power minus j of n minus 3 minus e power minus j 2 of n minus 3 plus e power j 2 of n minus 3 minus e power j of n minus 3. So in next step I will simplify further as, so here I will take this n minus 3 outside the bracket. Similarly I will send this 2 inside the bracket, therefore the denominator will be 2j. Now I will write these numerator terms as, first I will write this term, that is e power j 2 of n minus 3. Then I will write this term, that is minus e power minus j 2 of n minus 3 minus, I will consider this as one bracket. In another bracket I will write the remaining terms as, that is e power, I will write this term first, e power j of n minus 3 minus e power, here we have minus j of n minus 3 whole divided by 2j. So here we can see that we know that e power j theta minus e power minus j theta divided by 2j is equivalent to sin theta. So now I can write this as hd of n is equal to 1 over pi of n minus 3. So this is e power j theta, e power minus j theta divided by 2j, which is nothing but sin theta. That is, in this case, it is sin theta is nothing but 2 of n minus 3 minus, similarly here, this is also sin theta, sin, so theta in this case is 1 n minus 3. That is, simply I can write n minus 3. So further I can simplify this as I will take n minus 3 inside the bracket separately to first sine term and second sine term as hd of n is equal to 1 over pi. We have sine 2 of n minus 3 divided by n minus 3 minus sine of n minus 3 divided by, it is n minus 3. This as equation 1. So in this equation, if we consider if n is equal to 3, then we can see that here sine 0 by 0 form will get. That is 0 by 0 indeterminate, so which is not defined. So in this case, for n equal to 3, it will be simplified using L'Hospital rule. Therefore, using L'Hospital rule, that is, L'Hospital rule is defined as limit alpha tends to 0 sine a alpha divided by alpha is given by a. So similarly, now applying L'Hospital rule to equation 1, I can write hd of n is equal to 1 over pi. We have limit alpha tends to 0. Here we have sine 2 of n minus 3 divided by n minus 3 minus, for this term also I will apply the limit, that is limit alpha tends to 0 sine of n minus 3 divided by n minus 3. So simplifying this, I can write hd of n is equal to 1 over pi. So here we can see that sine a alpha, so here a is equivalent to 2 and alpha is equivalent to n minus 3. So sine a alpha divided by alpha is equal to a, that is, first case it is 2 minus, here we can see that sine n minus 3, alpha is n minus 3 and here we have 1. So it is 1, which is nothing but 1 by alpha. So therefore I can say hd of n, so n is 3, hd of 3 is equal to 1 over pi. So the next step is to obtain the impulse response h of n. That is, h of n is obtained by multiplying hd of n with window. Here the window is Hamming window. I will represent it as whm of n. Now let me define what is Hamming window. The Hamming window sequence is defined as, it is given by whm of n is equal to 0.56 minus 0.54 minus 0.46 cos of, we have 2 pi n divided by m minus 1, where n is in between m minus 1 and greater than or equal to 0 and its value is 0 otherwise. So therefore I can write WHM of n is equal to 0.54 minus 0.46. We have 2 pi n divided by m value is 7. Here m is equal to 7. So m minus 1 is 6. This is for n is equal to 0 to m minus 1. That is 0, 1, 2, 3, 4, 5 and 6. We'll call it as equation 2. So now h of n is obtained by multiplying hd of n with whm of n sequence. So here whm of n sequence I have written, and here this is hd of n sequence, that is equation number 1. Let me write equation number 1 once again here. So here this is equation number 1, that is hd of n. By multiplying equation 1 and 2 we will get h of n. So let's calculate h of n by taking different values of n from n equal to 0 to 6. Let me consider this table. The first column represents n value, that is n varies from 0, 1, 2, 3, 4, 5 and 6. By taking n equal to 0 in this equation number 1, we will get minus 0.0446. Similarly, by substituting n equal to 0 in equation 2, that is Hamming window sequence, we will get 0.08. Multiplying these two, we get minus 0.0035. Similarly, for n equal to 1, hd of n value will be 0.265 and this one will be 0.31. Multiplying will get 0.08215. Similarly, for n equal to 2, it will be 0.0215. WHM of n will be 0.77 and this will be 0.0165. Now for n equal to 3, as we know here, hd of 3 is equal to 1 by pi. 1 by pi, which is nothing but 0.318, and for n equal to 3, Hamming window sequence is given by 1 and its value is here 0.318. Now for n equal to 4, it will be same as n equal to 2 because of linear phase, that is 0.0215. This will be 0.77 and this will be 0.0165. Now for n equal to 5, which will be same as n equal to 1 because of linear phase, that is minus 0.265. Even by substituting y in these two equations, we will get the same thing, 0.31, and here we have minus 0.08215. Similarly, for n equal to 6, which is same as at n equal to 0, that is minus 0.0446, and here we have 0.08, here we have minus 0.0035. So therefore here h of n is the impulse response, that is impulse response is given by h of n is equal to, we are supposed to write all h of n samples, that is minus 0.0035, we have minus 0.08215, 0.0165, we have 0.318, 0.0165, we have minus 0.08215, and we have minus 0.0035. 3, 5. So here it is asked that magnitude response. Now we'll try to find the magnitude response. So in this problem, we can stop here finding h of n, but here we supposed to calculate magnitude response. Let me h of e power j omega is equal to h of m minus 1 by 2 plus summation n is equal to 1 to m minus 1 by 2 2h of m minus 1 by 2 minus n cos omega n. So one should remember this formula. Now I can write it as, therefore h of e power j omega is equal to, we have h of m is 7, that is 6 by 2 is 3, plus summation n is equal to 1 to m value is 7, 6 by 2 is 3, 2h of, here m is 7 minus 1, 6, 6 by 2 is 3, that is 3 minus n cos omega n. So same thing, I can represent it as h of e power j omega is equal to, we have h of 3 plus, I will expand this summation, that is 2h, this will be represented as 2h of 3 minus 1, that is 2 cos of omega, here n is equal to 1, plus 2h of, taking n equal to 2, that is 3 minus 2 is 1 cos of 2 omega, plus for n equal to 3 it will be 2h of 3 minus 3 is 0 cos 3 omega. Therefore I can write it as h of e power j omega is equal to, so here we can see that h of 3 is 0.318 plus 2 into h of 2 is, this is h of 2 value, that is 0.0165 cos omega, plus 2 into h of 1 is minus 0.08215 cos of 2 omega, plus 2 into h of 0 is minus 0.0035 cos of 3 omega. So therefore simplifying this, I can get h of e power j omega is equal to 0.318 plus 0.0332 cos of omega, plus here we have, it is minus 0.1644 cos of 2 omega, minus we have 0.0071 cos of 3 omega. So this is the magnitude response of the desired filter. Thank you for